Hey, this is Cody with Platform 9, and I just want to go over a couple quick things on Ironic with you. OpenStack Ironic is a very powerful tool for deploying bare metal services, and I got this up and running, and I'm provisioning our environment, so I thought this would be a good time to set up a video and kind of show it off a little bit. So the first place where you need to start is have a Linux box that's going to run as your Ironic conductor and inspector. Platform 9 supports CentOS for this. We will be adding Ubuntu support soon, but so far CentOS is what you want to do, CentOS 7. And you need to create some flat networks for Ironic to use. So in my case, I wanted to use VLAN 2005 for my provisioning network. So what I did is I created a subinterface. Ironic is all running in a virtual machine, by the way. You don't need to waste a physical host to host Ironic. So I'm spinning up a virtual machine for this. So I have a virtual machine with a single NIC. I have one for my management network where I can SSH into this box, default route, all of that. And that's on VLAN 2003. VLAN 2005 I'm using for my provisioning network for Ironic. So 2005 is actually an OVS port. It goes into this OVS bridge for BRPF9. And you'll notice BRPF9 has a few IP addresses on it. So this is the IP address that I want to use for my provisioning network, so 10.128.253.11, on this VLAN 2005 that's plugged into this bridge. I also have a gateway, an upstream gateway of .1 on this network, on this /24, and so we have a simple IP address on an OVS bridge, and it has a router on that same subnet. Now, this is another interface that Platform 9 will create for you, 198.51, 100.1, and this is used for specifically the Ironic inspector. And what the inspector does is if you power on a physical server, it will PXE boot immediately to the Ironic inspector. It will download a image from it, and then it'll start inspecting itself. How much CPU, how much RAM, how much disk, what architecture, IPMI information, that type of thing. It will then upload that to Ironic Conductor and actually create a profile for that bare metal piece of hardware. When it's done inspecting, it'll power it off, and we're going to walk through that in a minute. So that's what this space is for. This space does not need to be routable. It is purely a provisioning network that's on this same flat network here. So this is the physical host config. Pretty simple. You have your management network, whether it's a different physical NIC or a VLAN, but you need a flat network off to plug into your OVS bridge. So I'm tagging 2005 and I'm plugging this entire thing into OVS. So if we do an OVS-VSCTL show, we could see that BRPF9 here has this whole port into it. So it's basically a flat network for that 2005 VLAN. So that's important. So flipping over to the Platform 9 UI, you then need to set up your network, right? So we created that flat network in this environment, and we put our subnet on it. So that's the same subnet that you have a default gateway. So our provisioning IP address is for Ironic on that network is 253.11, 10.128.253.11. This IP address will be used for PXE booting operating systems. This IP address will be used for PXE booting the inspector. They get used separately. This one's for Ironic Conductor. This one's for Ironic Inspector. Two separate services. Okay. So we've set this network up. I've created a subnet. I've excluded my .11 interface out of this range. So I have a nice range for when physical servers boot and come online. They will join this network. Okay. So then I need to add some bare metal nodes. You can see I have in this environment 5 bare metal nodes already discovered, but we'll go ahead and discover a brand new one from the ground up. So before we do that, let me actually show kind of the authorization of this environment, right? So if we go here to configure this host, it's going to ask a couple questions. We're making this node a networking node as well, so it's going to run DNS mask on it. We're choosing that provisioning network and BRPF9 here, and we're setting up that network here for provisioning, as well as running DNS mask on this system as well. And we're running DNS mask on the IP address. We have a little UI bug here, but this is actually the IP address on BRPF9 for the 10.128.253.11 address space. So that's what we've chose here, and that's getting used. This system is also an image library, right? So you need to have all of your images that you want to make bare metal systems. And in bare metal environments, your images are a little different than other images. They come in 3 pieces. We're going to be using Ubuntu 16.04 for this. So you can see we have a RAM disk, a Ubuntu kernel, and then we actually have the QCOW2, which is actually the the larger image. The RAM disk is 37 megs, the kernel is 7 megs, and this is what's going to be actually copied to the disk when we boot. Okay, so let's go ahead and get started with provisioning a system. So I'm going to flip over to a Windows box that I have here because we're going to be jumping into a Java console, and it's easier to manipulate an older version of Java that I don't have on my production Mac. So I'm going to come over here to launch the KVM console for this physical node. We're just using a cloud Dell server, something we had laying around in our lab. All right, and so we're going to power this guy on, right? So we're powering on the system. Yep, we want to power it on. And this will take a little bit. I'll probably be fast forwarding the video here and there to cut out some of this downtime. So you can see that this system PXE booted here, and it got an IP address off that 198.51.100 space, right? It got .11, the gateway IP is .1. The .1 is actually our ironic inspector service. And so this thing's actually going to PXE boot from an image that we have here, a couple images, a RAM disk and a kernel. And something I forgot to mention about this is that you do want to make sure that the #1 boot order in all of your systems is PXE, and it's recommended to turn PXE off on every other interface other than the one interface that you want to PXE boot on. And make sure that your boot order is correct for the networks, right? So if you don't turn PXE off, make sure that the network you want to PXE boot on has the highest priority in the BIOS, or that NIC, as well as the root disk that you want to install to should be the highest hard disk priority in your system. So this thing's PXE booting now. It's coming up, and it's getting an IP address, and in just a minute it's going to start doing a bunch of things. It's going to run a bunch of tools and discover what its IPMI address is through IPMI tool. It's going to inspect all of the hardware on this system and try to get a really good profile or personality of this system. And when this is finished, we know it's successful because it'll be powered off. And it doesn't power itself off. It passes this data over to Ironic, and Ironic powers it off. So that's like, hey, look, we're good. We're able to connect, and we have IPMI access. Great. So this green screen on my environment means the system got powered off. So I'm going to jump back over here and do a little refresh here. And there we go. We have another system, and it's in the enroll state. So that's good. That's what we want. It came in. And Ironic automatically detected what its IP address is. And we actually set up some rules inside of Ironic, and I'm not going to cover it because it's kind of long, but to say what deploy kernel and deploy RAM disk, as well as what our IPMI username and password are. We created an inspection rule to pass that information to the system, and it detected its IP address using IPMI tool locally via that pre-boot environment. Now there's two things I want to do to this environment. The first thing I want to do is I want to set up the port that we want to use for the console. There's a TCP port that you have to select. I really wish it was auto-incremented from some list or something, but it's not. So we need to come in here and set up the IPMI terminal port. This is just a standard TCP IP port that's not used on the Ironic conductor system. I like to start with 5 for a 50,000 address and then use the last 4 digits of the IP just to kind of pseudo randomize it, and that works well for me. The other thing that we need to do in this environment is we need to change the capabilities. We're not going to tag off of any of these. We're going to keep it simple, but what we do want to do is we want to make sure the system boots from the local hard disk. Okay, so we're going to go ahead and save this guy. So now that we've booted from the local hard disk, or set it to boot from the local hard disk and set that console port, we can actually change the console to enabled. And what this is going to do is it's going to start a service on the Ironic conductor node to connect via IPMI tool when we request it to open up that console, which is pretty cool. So now that this is all set up and good to go, one of the last things we'll see is that this thing actually has a port on it as well. So it detected, hey, this is the MAC address of the main port that we're going to provision to. This is very important, and this is how provisioning in Ironic conductor works. So we'll go ahead and take this guy, and what we're going to do is provide it to Nova. So we go to provision state and change that to provide, and change the provisioning state. Oh, look at that. Oh, sorry, I skipped a step. We need to go to manage. And I don't know why they make you force through these things. I was able to manage the node just fine, but they force you to put it into a management state, and then they force you to put it into a provide state. And then this thing starts cleaning. So again, this thing's going to power on and go through a cleaning procedure. And what cleaning does, and there's a bunch of cleaning steps that you can customize and modify, but essentially it's to make sure that the system is in a regular routine state every time you provision. So when you deprovision a box or delete it, it will go back into cleaning and then set itself to available. So one of the main things that cleaning does is wipe the hard disks. Now we have it set just to wipe the master boot record, or the first so many bytes of the drive, to kind of wipe out that partition table. We're not wiping the entire hard drive. It takes too long. It's hard on the disks, and we're not in an environment where it causes an issue. But in some places, like especially a multi-tenanted Ironic environment where you have regulatory or whatnot, you can actually set full wiping of disks and have that do a DoD wipe. Other things that you can do with Ironic is configure switch ports and things like that. So maybe after provisioning, you modify the switch port that the system is in to be in a certain VLAN or something like that. So there's a lot of plugins for Ironic to do things like that. And you'd want to set that back after cleaning to the provisioning network and things like that. So those are the cleaning steps that you can go through, and you can add a bunch of them. The only cleaning step we have right now is to wipe that master boot record on that system, and that's about it. Notice when it pixie booted this time, it pixie booted to a 10 dot address, and we'll explain that in a minute when we actually provision the operating system. Okay, now that we're back to this green screen, that means that Ironic has powered this guy back off. And it's no longer in the cleaning state. Let's hope it's in a available state. It is. Great. So we're in an available state now, and let's go ahead and provision this guy. So what we want to do is go to instances, and let's spin up a new instance. So I have an Ubuntu 16.04 image here, and I had an issue with Ubuntu and a system booting and not having a COM1 port, so I had to modify this image to only listen on COM2 because the servers we have only do serial over LAN on COM2. So I have that. I have my Dell image with the same capabilities that we put on the physical box, right? So boot options equals local. And then these vCPU, RAM, and disk have to match identically with the actual system, right? So it's 32 vCPUs in megabytes. That's 128 gigs of RAM and 110 gig root disk, right? So those all need to match identically in order to be selected by the Nova scheduler. The other thing that needs to match, again, is those capabilities, right? Okay, so let's go ahead and spin this up. And now this is probably not going to pick the exact system we have because we have 6 identical boxes, but that's okay. It'll pick one of those 6, and we'll kind of see it go through its thing. Actually, let me set the other ones in maintenance mode because for this video, yeah. So we'll come over here, toggle maintenance, toggle. So now these won't be provisioned to, and we'll force it to the one that we want. Okay, cool. So maintenance is true and all but the one that we want, so now we're going to force it to this one. That way we can see the console and all that we have ready. All right, last time. Ubuntu 16, Dell system. We're going to put it on that flat provisioning network. That's the only network we have available to us. And go ironic. We're going to pass RSSH key. And we're going to force config drive here. Now, metadata service does work and it's available, but metadata service doesn't provide the OpenStack extra vendor tags and whatnot to your system because metadata service can't detect that your system's actually an OpenStack node. It thinks it's just a regular standard node. But the configuration drive does know you're an OpenStack node, so we're going to pass the data in that way. And we can even pass in some cool stuff. We'll set a default password of Winter Wonderland is fine, and we'll echo Hello World from PF9 into some temp files just to show that customization does work. Cool, so let's go ahead and create this system. So now the very next thing that happens here is a Nova port is created for this system. You can see Go Ironic has a Nova port here, and this is the port ID. Okay, so with this port ID, and we have some time to see this thing boot, we're going to source my OpenStack tools bin activate, punch in my password, and do an OpenStack port show this port number. And so this port has DHCP extra options. So it's going to say, hey, I want you to PXE boot to this PXE server, right? 10.128.2.3.11. I want you to download that file and whatnot, right? So this is all set up in the Neutron DHCP server is pointing you to this system. So if we go over here, we can see the system booting. It hasn't quite gotten to the boot parameters yet. It's just initializing the PXE BIOS on all of these systems or cards. All right, so now we're going to PXE boot. So we're pixie booting here. There it goes. 10.128.253.24 is the IP address that it got, and it's set to download from .11 and to download that pixie0 file, and it did. Okay. Now that pixie0 file actually told it to download these other images. These images got deployed. The deploy kernel and deploy RAM disk got deployed to the Ironic system and put inside of that folder. So it's downloading those guys and actually booting the Ubuntu environment. Okay, so the Ubuntu environment's going to come online. It's going to then copy that QCOW2 image to disk and then reboot the system. When the system reboots, Ironic is going to say, hey, the reboot was successful and I'm done, right? And the instance is going to go into an available state. But it's not quite available yet because it has to reboot. So it takes a while to reboot. Servers, up to 5 minutes or so. So about 5 minutes after the system goes available, we can actually log into this guy. So I'm going to go ahead and fast forward the video, and we'll get back to that. Okay, this system is now being rebooted. So we can actually go ahead and take a look here on the instances page. So it still says spawning, but in just a minute it's going to go green and available as soon as it powers it back on, and then is able to do an IPMI status to know that, hey, I got it, there it goes. So we're in an active state here. That's good. We were able to go ahead and deploy this environment, get it up and running. This is our IP address that we should be able to use to SSH into this box. So again, fast forwarding the video here until we're fully booted and can log into this guy. Okay, this system's back up and running now. So a couple things that should be cool is we should be able to open up this console. Now, before I click this button, we are going to get an error in our UI. I'll go ahead and close that out. We need to get this fixed. We need to open the console in a new window, and it opens up Shell in a Box from IPMI tool. So you notice that we named this Go Ironic, and we should be able to log in using Ubuntu and that Winter Wonderland password that we set via the tools, right? The user data. So I should be able to go here, and I was having a hard time sudoing. I wonder if network is down. Maybe it's not finished customizing. Okay. So we should be able to ls/temp, and the pf9.txt is there that we also did, right? So we're realizing that that works. Hello world from pf9. The other thing that does work is if we do an ls block on this guy, we'll notice that we have a very small partition, SDA1. And I don't believe it's mounted anywhere. And it's not, so we can mount that guy /dev SDA1, and it's mounted as read-only because it is a CD, so to speak. It's like a CD-ROM drive type partition. But this is the config drive. This is how they do the config drive, is they write that to the first partition, and then you could see in here we have EC2 and OpenStack. So if we go into OpenStack latest, we should be able to cat our user data, and there it is, right? There's that user data that we passed in. So all that works and works pretty well. I'm going to see what's going on with this IP address. It looks like we did not get an IP address on this system. So I'm going to run a DH client on ENP3 S0F0 and see if we can get a DHCP address. There it is. Have no clue why we didn't get an IP. That's the first time it's happened to me, but we have one now. So I should be able to, from this box here, let me open up a new tab, SSH to the IP address that we find in the console. And this is important for automation purposes, right? So if you want to provision a bare metal box and then use Ansible or something like that to finish the last mile, you need to predictably be able to, or programmatically be able to get that IP address and log into it. And notice I didn't get prompted for a password because my SSH key got pushed to this. So I could do Ansible directly to this system, and all of that worked. So we have a full provision here. You could see, I think if I do a DMI decode, probably have to do sudo for that. Pipe grep -I del, that this is a Dell system, right? So we did get provision on top of that Dell box. It is physical free -HM should show us that we have 128 gigs of RAM, just like the flavor showed. And ls block should show that 120 gig disk, 110 gigs, right? Yeah, so this is just a quick run through of Ironic and bare metal provisioning in this environment, and I think this is a really powerful features for provisioning the bare metal hypervisors that you might use for your OpenStack cloud, or provisioning the bare metal container hosts that you might use for a Kubernetes environment. So I'm pretty excited about it. Hopefully you are too. Thanks.